Hello everyone, myself Bhagyashree Desai, subject physical chemistry. Today we are going to learn the topic of spectroscopy, unit number 2nd, spectroscopy. Before going to this topic, we should see what is the spectroscopy. Here, spectro means radiation and scopy means measurement. Okay, here spectro means radiation and scopy means measurement. Okay, measurement of radiation is nothing but spectroscopy. Okay, measurement of radiation is nothing but spectroscopy. Now we can see that the introduction of spectroscopy. Introduction. Spectroscopy is the study of Spectroscopy is the study of interaction of electromagnetic radiation with matter. Okay, spectroscopy is the study of interaction of electromagnetic radiation with matter. Now we can see that atomic spectra and molecular spectra. Atomic spectra. What is the atomic spectra? Atomic spectra involve the transition of electron from one energy level to another and consist of sharp line known as line spectra. Okay, atomic spectra involve the transition of electron from one energy level to another and consist of a sharp line known as line spectra. Now we can see that molecular spectra. Molecular spectra. Molecular spectra involves transition between rotational and vibrational energy level in addition to the electronic transition. Okay, molecular spectra involve the transition between rotational and vibrational energy level in addition to the electronic transition. Now we can see that what is the difference between atomic spectra and molecular spectra. Okay, atomic spectra are the transition of electron between the electronic energy level in an isolated atom, and molecular spectra involve transition in molecule with the two or more atoms, either same or different. Thus, molecular spectra are the much more complicated than atomic spectra. Okay, molecular spectra are the much more complicated than atomic spectra. However, they are of the great importance to give the information about size and shape of molecule. Size and shape of molecule, and about the certain important parameter like bond length, bond angle, and bond strength, and dissociation energy of molecule. Dissociation energy of molecule. The spectroscopy is the powerful tool for studying the matter. The present chapter, spectroscopy, is a deals with the molecular spectroscopy. Okay, this present chapter is deals with the molecular spectroscopy, that is the rotational, vibrational, and Raman spectra of the atomic molecule. That is rotational, vibrational, and Raman spectra of the atomic molecule. The atomic molecule. Now we can see that electromagnetic radiation. Now we can see that the next point is electromagnetic radiation. Electromagnetic radiation. Okay. Electromagnetic radiation is a form of energy that is transmitted through the space at the very high velocity. Okay. Electromagnetic radiation is a form of energy. Is a form of energy that is transmitted through space at very high velocity at okay. Electromagnetic radiation is a form of energy that is transmitted through a space at a very high velocity. Now, the scientist Maxwell proposed that light consists of an electromagnetic waves. Maxwell proposed that light consists of electromagnetic waves. Okay, the scientist Maxwell proposed that the light consists of an electromagnetic waves. Now, electromagnetic waves are the oscillating electric and magnetic field perpendicular to each other. Electromagnetic waves are electromagnetic waves are oscillating electric and magnetic field perpendicular to each other and are perpendicular to the direction of motion of the wave. Okay. Electromagnetic waves are the oscillating electric and magnetic field perpendicular to each other and are perpendicular to the direction of motion of the wave. The electromagnetic radiation can thus be described as wave with the properties of wavelength, frequency, and velocity. Electromagnetic radiation does not require any medium for its transmission. Thus, it is easily passes through the vacuum. Now, we can draw the diagram of propagation of wave. Here, displacement this one is wavelength. Here also this one is wavelength. It called crust, and this one is trough. Okay, here the crust and here the trough. And the next one is, we can draw the here the distance between this velocity, here 1 second, and this one is direction of propagation. Your figure propagation of wave. Okay, here this one displacement, here this one the distance between crust or trough is the wavelength, here the velocity, and this one is the direction of propagation. The electromagnetic radiation possesses the following properties. The property first one is wavelength. First one is wavelength. The symbol indicated by the symbol is lambda. Okay, so what is the wavelength? Wavelength of wave is the distance between two successive crust or trough. The distance between successive crust or trough is the wavelength. Okay, wavelength of wave is the distance between successive crust or trough. Okay, common unit distance between successive crust or trough. Common unit of wavelength include angstrom or micrometer, nanometer and picometer. Okay, here 1 angstrom unit is equal to 10 raised to minus 8 centimeter is equal to 10 raised to minus 10 meter. What? 1 angstrom unit is equal to 10 raised to minus 8 centimeter and 10 raised to minus 10 meter. And 1 micrometer is equal to 10 raised to minus 6 meter. 1 micrometer is equal to 10 raised to minus 6 meter. Okay, and 1 nanometer is equal to 10 raised to minus 9 meter is equal to 10 angstrom unit. 1 nanometer is equal to 10 raised to minus 9 meter and this one is 10 raised to 10 angstrom unit. And 1 picometer is equal to 10 raised to minus 12 meter. What? 1 picometer is equal to 10 raised to minus 12 meter. In spectroscopy, nanometer is the most frequently used. Okay, this one is. Okay, in spectroscopy, nanometer is the most frequently used. In spectroscopy, nanometer is most frequently used. Okay, wavelength. Here wavelength is finished. This one is the property first. The next upon we can see that the property number second and this one is the frequency. Okay, the second number property is frequency. Okay, frequency, it is indicated by the symbol mu. What is the definition of frequency? Frequency of wave is the number of cycles passing a given point per unit time. Okay, frequency of wave is the number of cycles passing a given point per unit time. Okay, what is the frequency? Frequency of wave is the number of cycles passing a given point per unit time. Here the unit of frequency is hertz. Unit of frequency is hertz unit. Okay. Here the various multiple of hertz such as kilohertz, okay, megahertz, gigahertz are also used. Here 1 kilohertz is equal to 10 raised to 3 hertz. 1 here 1 kilohertz is equal to 10 raised to 3 hertz, and 1 megahertz is equal to 10 raised to 6 hertz. 1 kilohertz is equal to 10 raised to 3 hertz, and 1 megahertz is equal to 10 raised to 6 hertz. Okay, and 1 gigahertz is equal to 10 raised to 9 hertz. 1 gigahertz is equal to 10 raised to 9 hertz. In spectroscopy, frequency is generally expressed in a second inverse. In spectroscopy, frequency is generally expressed in second inverse. Okay, now the property number third, velocity. See, what is the velocity? It is the distance traveled by the wave in a unit time. It is the distance traveled by the wave in unit time. Okay, what is the velocity? It is the distance traveled by the wave in a unit time. In the graph, you can see it is the distance traveled by the wave in a unit time. This one is the velocity. Okay, here velocity is expressed in centimeter per second or meter per second. Centimeter per second or meter per second. In vacuum, light travel at its maximum velocity equal to 3 into 10 raised to 8 meter per second. Okay, the next property is, fourth number is wave number. Mu bar. It is a reciprocal of wavelength. Okay, wave number is, it is reciprocal of wavelength. Okay, wavelength means lambda. Reciprocal of wavelength means mu bar is equal to 1 upon lambda. Here the wave number is expressed in centimeter inverse or meter inverse. SI unit, approved unit of wave number is meter inverse, but centimeter inverse used almost exclusively. The wavelength, now the wavelength, frequency, velocity and wave number are related by the expression. Okay, what? All these properties means, first one, wavelength, frequency, velocity and the wave number are related by the expression is equal to C upon lambda is equal to bar, C into mu bar. Okay, the electromagnetic radiation consists of various types of radiation such as the visible light, ultraviolet light, infrared, X-rays, radio waves, etc. All types of radiations travel at the same speed of light, that is C is equal to 3 into 10 raised to 8 meter per second. Okay, now this one is the relation between all these properties. Okay, the electromagnetic radiation has a dual nature as a wave and particle. The light is therefore considered to consist of photons or quantas. The energy of single photon is given by E is equal to H mu is equal to H into C upon lambda is equal to H into C into mu bar, where H is equal to, H is a Planck's constant. It is evident that the higher the frequency or lower the wavelength of radiation, higher is the energy. Okay, here the electromagnetic radiation point is finished. Thank you.